This is Bob Capetta from the University of Illinois at Chicago, and this lesson is on trig functions in the four quadrants. So we know the trig functions for 30 degrees, pi over 6, 45 degrees, pi over 4, 60 degrees, pi over 3, as well as all of the values on the unit circle like 1, 0, 0, 1, etc. But we're thinking about what's going to happen if we are in one of the other quadrants. So I've got 4 points. I've got one in quadrant 1, one in quadrant 2, one in quadrant 3, and one in quadrant 4. Now, the x value represents cosine and the y value represents sine. You'll notice x and y are both positive in quadrant 1, so cosine and sine are both positive. Here, x is positive, but y is negative, so cosine is positive, sine is negative. In quadrant 3, x is negative and y is negative. So cosine is negative and sine is negative in quadrant 3. And up here in quadrant 2, what do we have here? The x value is negative, but the y value is positive. So cosine is less than 0 and sine is greater than 0. So we want to keep all these ideas in mind. Again, cosine is an x value, sine is a y value. So in the first quadrant, x and y are positive, so all the trig functions are positive. In quadrant 2, you'll notice the y value is positive, so sine is positive. In quadrant 3, what am I saying there? I'm saying tangent is positive in quadrant 3. Because if sine and cosine are both negative, tangent is sine divided by cosine. That would make tangent positive. And in the fourth quadrant, again, we can see that x is positive. So cosine is positive in the fourth quadrant. So we need to see what quadrant we're in to determine the sign, and then know what happens with our reference angle. So that'll be our standard process here. So what we're going to look at here is theta is equal to 3 pi over 4. It's supposed to be a theta. We want to see where 3 pi over 4 is. So let's think about that for a second. Pi is all the way from 0 to 180. That's pi. 3/4 pi is 3/4 of the way there. So if I'm 3/4 of the way there, I am 1/4 of the way not there, so I'm pi over 4 away. So I'm in the second quadrant, and my reference angle measured with the x-axis will be pi over 4. So let's take a look at our picture there and see what that's going to look like. That's where 3 pi over 4 is located. Now, if we're in quadrant 2, what's positive, what's negative? Quadrant 2, sine is positive, cosine is negative. The y value is positive, the x value is negative. So sine is positive, cosine is negative. So knowing that then, the sine of theta will be a positive value, positive of the reference angle. So what we're going to say there, positive of the reference angle. What is the reference angle? What is the measure from 3 pi over 4 to here? That's pi over 4. So we always establish our sign first and then evaluate it at the reference angle. So it's positive sine of pi over 4. We know what that is. Sine of pi over 4 is 1 over root 2. So we get an answer of positive 1 over root 2. Now how about cosine of 3 pi over 4? Let's talk about this one. It is in the same location, but in quadrant 2, cosine is negative. The reference angle is still pi over 4. To get from here to here, it's pi over 4. So the sign is negative, and I'm going to say negative cosine of pi over 4 is what we're going to get here. So what is the negative of the cosine of pi over 4? Cosine of pi over 4, also 1 over root 2. So my answer in quadrant 2 will be negative 1 over root 2. And I'm going to finish up with tangent. The tangent of pi over 4 is simply the sine of pi over 4 divided by the cosine of pi over 4. So we can see how that's going to behave. Sine of pi over 4 divided by the cosine of pi over 4. We have these two values here. One of them is positive and one of them is negative. So of course in this quadrant the tangent is going to have to be negative. What do we get? We get 1 over root 2 divided by negative 1 over root 2, which is just simply going to be equal to negative 1. So those are some of our basic angles for us to work with. Now we'll take a look at a couple other sorts of problems here. Let's see what comes up. We want to get the 6 trig functions this time. 6 trig functions: sine, cosine, tangent, secant, cosecant, cotangent. We'll try to do all 6. And we are looking at 11 pi over 6. Now let's think about where that is. 11 pi over 6. 2 pi is 12 pi over 6. So 11 pi over 6 is just a little bit short of 12 pi over 6. 11 pi over 6 is a little bit short of 2 pi. So let's think about this. Let's visualize it and come up with our functions. So as I've said here, 2 pi is 12 pi over 6. So 11 pi over 6 is what? Is 1 pi over 6 short? So we're not quite there. We're just missing it. Which means my reference angle is going to be measured from the x-axis. That's just going to be pi over 6 short of 2 pi. So let's see that picture. There's pi over 6, there's 30 degrees, short of 2 pi. Now, I want to get all 6 trig functions. What quadrant is that? 1, 2, 3, 4. You'll see x is positive, but y is negative. So sine should have to be negative there because the y value is negative. But cosine should be positive. So cosine is positive there because the x value is positive. Now I've done the hard work because I've got the reference angle here of pi over 6. So if sine is negative, the sine of 11 pi over 6 will be negative the sine of pi over 6. The reference angle indeed is pi over 6. So we always need our reference angle when we're doing this sort of argument. Again, we're in quadrant 4, sine is negative. So sine of 11 pi over 6 is going to be negative something, negative sine of the reference angle, negative sine of pi over 6. We know sine of pi over 6 is a half, negative a half. Now cosine of 11 pi over 6 will be positive. Fourth quadrant cosine is positive. Cosine of the reference angle, cos pi over 6, positive root 3 over 2. Now if we want to get tangent, tangent is sine divided by cosine. So if I want the tangent of 11 pi over 6, I will take the sine of 11 pi over 6 divided by the cosine of 11 pi over 6. And what is that going to give me? We're going to get negative 1/2 divided by positive root 3 over 2. So a negative divided by a positive will be negative, and I think the result is going to be negative 1 over root 3, or negative root 3 over 3. Now, to get the other functions, we're going to think reciprocal. So the cosecant of theta, sorry that's hard to read, is 1 over the sine of theta, which is 1 over negative 1/2, which is negative 2. The secant of theta is 1 over the cosine of theta, which is going to be 1 over root 3 over 2, the reciprocal of root 3 over 2, which is going to be 2 over root 3. And the cotangent of theta is going to be what? The cotangent of theta is going to be the cosine divided by the sine, or 1 over the tangent. You could do it either way. If I'm doing cosine divided by sine, that's root 3 over 2 divided by negative 1/2, and that'll just be negative root 3. So we've got all 6 trig functions for that 11 pi over 6. Now, this time, what am I going to do? This time I am going to go ahead and determine what the 6 trig functions are for all of the 6 trig functions for this angle theta, which starts at 0, 0, and ends at negative 6, negative 8. So again, the direction says find the 6 trig functions for that angle. So what do we have to recognize? Well, it's got to be on a circle. And I'm going to need to get the radius of that circle. What do I know? X squared plus y squared is going to equal r squared. X squared plus y squared is going to equal the radius squared. So it'll give me negative 6 squared plus negative 8 squared is the radius squared. Go to capital R here, a little easier to see. So what do I get? I get 36 plus 64 is r squared, or 100 is r squared. So the radius of that circle is 10. Now, how can we use that to determine sine, cosine, tangent, etc.? What do we know? Well, certainly in quadrant 3, sine and cosine are both negative. Yes? So sine is negative and cosine is negative. But we also can define these functions. How can we define these functions? We can recognize that the sine is y over the radius. In a unit circle, the radius is 1. Cosine is x over the radius. And recognizing they're both negative, but you'll see y is negative and x is negative, so we sort of get that for free. Sine of theta is y over r. The y value is negative 8 over the r value is 10. So we get negative 4/5 is sine. Cosine theta is x over r. The x value here is negative 6. Negative 6 over 10. I'll get negative 3/5 there. Tangent of theta is sine theta over cosine theta. What's that going to give me? Negative 4/5 divided by negative 3/5. Which is going to give me 4/3. Negative times a negative is positive 4/3. Now the reciprocals. Cosecant of theta is reciprocal of sine. So we're going to flip sine upside down. So 1 over negative 4/5 is going to be 5 over negative 4. Or negative 5 over 4. The secant of theta is reciprocal of cosine, so flip negative 3/5 upside down. You're going to get negative 5/3 for secant. And cotangent, we can use the reciprocal of tangent. That's easy enough here. Cotangent of theta is 1 over tan theta. 1 over 4/3, of course, is just equal to 3/4. And that will conclude this lesson.